Okay, so as we move into section 7.4, let me just paint the difference between what we just did and what we're about to do. In the previous lesson, we were concerned about getting really familiar with some popular angle measurements, trig values of particular angles like the 30, the 45, and the 60. And we use special right triangles to help us get familiar with those. But in reality, even though those are very popular and we need to be familiar with them, we also need to be able to find trig functions of any angle that we're asked to find the value of. And so the way we do that is to take angle measurements that are not 30, 45, 60 and use what are known as coterminal angles and reference angles to help us convert them into those more familiar trig values, the 30, the 45, and the 60. So just by way of introduction, I just wanted you to see where we're going. And now let's take a look at exactly what this lesson is going to be all about. This first slide, just as a way of helping you understand the signs, S-I-G-N-S, of values of cosine and sine and tangent in the various quadrants. Some people, somebody came up with this. This is not original with me. But if you think about the statement, all students take calculus, I know that's not true, but it kind of helps us remember what the signs are for trig ratios when they fall within each quadrant. And that's going to be pretty important for what we're going to talk about in today's lesson. The A means that in quadrant 1, everything's positive. Sine, cosine, tangent, and all the reciprocals, everything is positive in quadrant 1. In quadrant 2, the S means that only sine is positive. And of course, if sine is positive, then the reciprocal of sine, which is, what's the inverse of sine? Cosecant is positive. So the S means sine is positive in quadrant 2. In quadrant 3, tangent is positive, because if both of these are negative, remember another way of representing tangent using a fraction? Sine over cosine, negative divided by negative is positive. So tangent is positive in quadrant 3, and then cosine, the C in calculus, means cosine is positive in quadrant 4. So another thing that you should always keep in mind, I think we've mentioned this before, you can always associate the x-coordinate of an ordered pair with cosine. Make that connection. The y-coordinate within an ordered pair always matches up with sine. Okay, so with that said, let's take a look at some problems like you're going to do 11 through 20. And let's just read through the directions. A point on the terminal side of an angle. Remember, an angle has two sides. We talked about this way back at the beginning in lesson 7.1. This side of the angle is called the initial side. The initial side of an angle is always the positive x-axis. And then this other side that makes up the angle is called the terminal side. So the green part of the angle is the terminal side. It's in quadrant 2. And the angle goes through this point, negative 3, 4. All right? And what we're supposed to do is find the exact value of each of the 6 trig functions, sine, cosine, tangent, and then all of the inverses. All right, so here's what we're going to do. We're going to take this terminal side going through negative 3, 4, and let's just turn it into a right triangle. So I'm just going to drop a line straight down, and I'm going to form a right angle. Okay, theta will always be this angle here, near the origin, when you make this right triangle. Now, if this is the point negative 3, 4, then that tells me that this leg has to be measured at 3 units, because it's 3 this way, and this leg has to be measured at 4 units. So now I just have to use the Pythagorean theorem and find the hypotenuse. So go ahead and do that. Okay, have you found the hypotenuse? What is it? What is it, Cody? 5. Everybody find it? And now that we found it, we're ready to identify all of the 6 trig ratios, the values of those trig ratios, but we got to be careful because remember on the previous slide, in quadrant 2, what is positive? Which of the trig ratios is positive in quadrant 2? Sine is positive. So cosine is negative. Just think of the x-coordinate in quadrant 2. That always relates with cosine. All right, so let's come up with our ratios. Cosine for this angle theta, cosine is always adjacent over hypotenuse. But you really have to be careful because since the terminal side is in quadrant 2, I can't say cosine is 3/5. It's negative 3/5. Because the x-coordinate in quadrant 2 is negative, and the x-coordinate and cosine always go together. Sine, for this particular angle, sine is positive in quadrant 2, and for theta, sine is always opposite over hypotenuse, and so sine will be 4/5. All right, tangent for this angle theta, tangent is always opposite over adjacent. The opposite side is 4, the adjacent side is 3. Well, is tangent positive or negative in quadrant 2? Well, if tangent is sine divided by cosine, and one of them is positive and the other one is negative, that means tangent has to be what? Negative, because a positive divided by a negative is negative. So, again, the angle theta opposite over adjacent, that should be negative 4/3. So the biggest mistake that people make in this lesson is writing down the incorrect SIGN for the values of the trig functions. They don't pay attention to the quadrant that the terminal side falls in. And now we just have to come up with the inverses and we'll be done. So the inverse of cosine is secant. And if cosine is negative 3/5, then that means secant is negative 5/3. The inverse of sine is cosecant. Sine was 4/5, cosecant 5/4. Obviously, the inverse of tangent is cotangent. If tangent was negative 4/3, cotangent is negative 3/4. And that's the way these problems work in 11 through 20. Any questions so far? All right, let's try this one. Same idea. Just this time we have a reference angle, the terminal side of an angle that falls this time in quadrant 3. And it goes through this point. So just think, drop a perpendicular line to form a right angle, make a right triangle. You always position theta in the interior, closest to the origin. So if you're wondering, well, how do I know where theta is? For these problems, theta is always this angle represented by the green terminal side and the x-axis. Well, if that's the point negative 3, that means each of these legs have to be measured at 3. So find the hypotenuse using the Pythagorean theorem. Anybody found it? What is it? 3 root 3. Everybody get that? Any questions? Okay, now let's work through our 6 trig ratios. We'll just start with sine. What is sine here for theta? John?
Negative 3 over 3 square root 2, or 3 square root 2.
That should be the square root of 2, shouldn't it? Not.
Yeah, that's what I thought.
Did you say 2 and I just misheard you, Stacy? It should be 3 square root of 2. Okay, now John, rationalize that because we can't have a radical in the denominator.
Negative 1/6.
Let's see, you started off with negative 3 root 2 over 6.
Do you not multiply the 3 in front of the square root of 2?
In this case, we are multiplying them, but you can't, they're not like, so you can't just combine them into one term.
So it would be square root of 2 over 2.
The square root of 2 over 2, and it would be negative. Okay? Bailey, what about cosine? Same thing, exactly, because these two legs measure the same thing. Okay. Lily, what about tangent? Positive 1. All right, now let's do the inverses. Ruthie, what is the inverse of sine? The inverse of sine is cosecant. It's all right. 3 root 2 over 3, positive or negative? Okay, and you can actually reduce here, and you actually need to. These 3's would cancel. So it actually reduces to the negative square root of 2. Okay, what's the reciprocal or the inverse, Shelby, of cosine? And what is that called? The inverse of cosine? Secant. And you said it's negative root 2. And then obviously cotangent is going to be 1. Any questions so far? Think you got it? Okay, I want you to try this one on your own. We'll come back together in just a minute and see if you get it right. Okay, so we went ahead and we found the measurement of the hypotenuse using Pythagorean theorem. And we're now ready to walk through all of the trig ratios now that we know the 3 sides of the right triangle that we created. So let's see, Cody, what is sine theta? 1/2. And Shelby, what is cosine theta? What did you say again? Square root of 3 over 2. All right. And what is tangent theta? Stacy. Square root of 3. Who got all those right? Okay, let's see, 4 people, 5 people. Anybody have a question? Do you need to see how we got any of those 3? Tangent, okay. Tangent is also known as sine over cosine. So if you know what sine is, put that on the top of your fraction. And remember, dividing by the square root of 3 over 2 is the same thing as multiplying by its reciprocal. And when you, so just think of it as multiplication, and the 2's will cancel. And when you multiply these together, it starts as 1 over the square root of 3, but when you rationalize, it should be the square root of 3 over 3. Anybody get the square root of 3 over 3? Does that make sense? Any questions on tangent? You can always do tangent as the ratio of sine over cosine. You got that right? The tangent part? Ruthie did? You did? Any questions? Okay, now let's work on the reciprocals. They'll be pretty easy. For cosecant, we just do the reciprocal of 1/2. That's 2. For secant, you just flip over square root of 3 over 2 and rationalize 2 over the square root of 3, and then we rationalize it. So that's 2 root 3 over 3. And cotangent, that's just cosine over sine, or you can just take tangent and flip it over and rationalize. It starts off as 3 root 3 over 3, but you can cancel the 3's, and so that's just the square root of 3. Okay, so do you think you get it? Because you're going to be doing this yourself in just a little bit. Any questions? And the great thing about quadrant 1 is we don't have to worry about anything being negative. Everything's positive when the terminal side of the angle falls in quadrant 1. Okay, so we're going to shift gears, and the rest of this part of the lesson we'll talk about coterminal angles. Coterminal angles, pretty simple definition. Co means they share. Terminal, we know what the terminal side of an angle is. We've talked about that already. So this is very simply 2 different angles that share the same terminal side. And I'll show you a couple of examples. What I've drawn here is the angle that's measured at 450 degrees. I went all the way around 360 plus another 90. Well, the angle measured at 450 degrees is coterminal with the angle measured at 90 degrees. That probably makes sense. If I just draw a 90-degree angle, which is that, those 2 angles, even though they have the different degree measurements, they have the same terminal side. That's what it means to be coterminal. Here's another example using radians. If I go all the way around a circle, that's 2 pi. And then I went another 1/4 of a pi, so 2 pi, which is another way of saying 8 pi over 4, plus 1 pi over 4, that's 9 pi over 4. Well, that's the same thing as the angle measured at pi over 4. They have the same terminal side. And you're going to see where this really comes in handy when we're asked to find trig values for these angles that are really big, and we're not as familiar with those, but using this idea of being coterminal can take an angle like 9 pi over 4, which I'm not familiar with, and I can make that the same as pi over 4, which is the same thing as 45 degrees, and we are familiar with that. We've been studying those 30, 45, 60 degree angle measures and all the trig ratios that apply to them. And so this idea of coterminal angles will really come in handy when we are given large angles, and we can put them in more familiar terms. All right, so let's just take a look at some examples. Use a coterminal angle to find the exact value of each expression. Well, we haven't studied very much sine 405 degrees. In fact, we haven't studied it at all. However, we have studied sine 45 degrees. So let's use this idea of a coterminal angle. Let me show you what 405 degrees looks like. That's 360 plus what? 45. Okay, so this is a rough sketch of 405 degrees. Well, that's coterminal with 45 degrees. So instead of having to remember what is sine 405 degrees, I really just need to know sine 45, because coterminal angles have the same sine value. And what is sine 45 degrees in fraction form? Square root of 2 over 2. So you're back to the knowledge that you gained with your special right triangles, that 45, 45, 90. So the whole idea is to take a pretty large angle and convert it into a pretty common angle. These are the same. If two angles have the same terminal side, then they've got the same trig values. Okay, let's try another one. What about tangent 405 degrees? Well, again, 405 degrees is coterminal with 45 degrees. And so let's use what we know about tangent 45 degrees, and that will be our answer. What is that? So what's that, Lily? Tangent 45? Do we need to do a special triangle? Or you can look back in your notes if you need to. 1. Now the thing to be careful with is pay attention to where this terminal side falls. So far we've done a couple of examples where the terminal side fell in quadrant 1. But we've already looked at when this terminal side falls in other quadrants, that's going to affect the signs, S-I-G-N-S, of the trig values. Okay, case in point, let's try this one. What is the angle that is coterminal with 450 degrees? 90 degrees, okay? So let's talk about the 90 degree when it's a quadrantal angle. We're going to be talking in depth about the unit circle. So let me just go ahead and introduce the unit circle for you. On the unit circle, at these quadrantal angles like 90, 180, 270, 360, just think about y-intercepts, and the unit circle always has 1. It's a distance of 1 from the origin all the way around. Okay, so when you're looking at these quadrantal angles, you can use these ordered pairs to represent cosine and sine. Remember, cosine relates to x, sine relates to y. So for that quadrantal angle, the 90 degrees, cosine is 0. Sine is 1. Okay, let's just go all the way around. What is cosine 180 degrees? Yeah, just look at the x-coordinate and you got it. So cosine 180 is -1. What's sine 180? 0. All right. Let's go to 270. What do you think cosine 270 degrees is? Well, what's that ordered pair right there? Right there, what is that dot if we're 1 unit from the origin? 0, negative 1. So what's cosine 270? Yeah, it's just the x-coordinate. What's sine 270? Negative 1. Okay, when we go all the way around, it's a terrible circle. What's that ordered pair? 1, 0. What's cosine 270? 1. Sine, I'm sorry, 360. What's cosine 360? It's 1. Sine 360. Okay? Do you see what I'm doing here? Cosine is x, sine is y, and this is an introduction to a future lesson on the unit circle. So now that you know this references, these are coterminal, what is the inverse of cosecant? Sine. So if we know what sine 450 is, it's the same thing as sine 90. What's sine 90? 1. And what's the inverse of 1? Still 1. So my answer for number 25 would just be 1. Okay, question? Does that make sense? So tell me again, John, what is sine 180 degrees? Well, cosine is x, sine is y. So sine 180 is 0. Lily, what is cosine 90? 0. Ruthie, what is sine 270? Negative 1. Bailey, what is sine 180? 0. Shelby, what is cosine 270? 0. I think you got it. Good job. So now you have a little bit of an introduction to the unit circle. Okay? Sometimes they're going to give you angle measurements in radians, and I don't think you have to convert them. The easy thing to do is just take I call this kind of the root. You know, we have root words. Well, the root angle out of all this is just pi over 4. If we actually went all the way around 33 pi over 4, we would end up in the same place as if we just did pi over 4. And pi over 4 is the same thing as what degree? That's a 45 degree. So what is cosine either pi over 4 or 45 degrees? Root 2 over 2. So this idea of coterminal angles is really handy. Okay, let's think about 21 pi. Remember, this is all the way around is 2 pi. So we're going all the way around 2, 4, 6, 8, 10, and then I'm going to do what? I'm going to end right here. Can you see that? If I go around 2, 4, 6, 8, 10, 5 times, and then I do 1 pi. So where am I? What ordered pair? I'm at negative 1, 0. Well, we know what cosine is there. What is it? Negative 1. Sine is 0. Well, how do we represent tangent? It's the ratio of sine over cosine. Okay, tangent is another way of saying sine over cosine. Or in other words, 0 over negative 1, which is 0. Did I lose anybody? You think you get it? I'm going to give you a chance to practice some. Okay, that's the assignment. We'll work on it. I'll be available for help if you need it.